So we'll go ahead and get this started. So Nathan showed us how data applies to land and how that's really driving decisions of where things want to be. Behind the scenes, he and I have collaborated on locating factories, advanced manufacturing and e-commerce facilities using that very location science that you've seen, because we want to start smart. And so what we're going to do now is, in my practice and at our company, we are very focused on autonomous vehicles and autonomous systems. We've been in that arena now for almost 5 years, and I've only been doing it for 5 years. That's because 5 years ago, you couldn't find somebody that knew how to do it, so we started, pretty much before anyone else did. And that's how we got going in it. So what I'm going to do is start by giving you an overview to the industry. And I think that's going to help give you context for what's already out there. Once we kind of understand what's out there, we're going to dive in super deep and we're going to see what e-com and advanced manufacturing is doing. So first, we're going to look at what's happening on the road. And there's really kind of 3 sectors, as I view the industry, of what's happening on the road. Number one, there's last mile. So that's the little last mile vehicle you see that's doing a grocery delivery or a parcel delivery. There's a lot of startups getting a lot of funding right now for doing this kind of to the curbside, to the front door delivery. And you notice that the form factor of the vehicle is just built around delivering the goods. It might even drive on the sidewalk in some future instance. The next one is the robo-taxi. I've got a Waymo vehicle up there. And Waymo, which was founded by Google, is really driving the industry. They have live robo-taxi in both Chandler, Arizona, in the Phoenix suburbs, and also in San Francisco right now. Waymo has demonstrated the ability to operate on a level 5 autonomy. I got to stand in here 2 or 3 years ago and we talked about levels 1 through 5. At the time, nobody was going beyond 4. So today, Waymo is operating at level 5. They are still, for the most part, using safety drivers just to make sure that the technology is successful, but the tech is driving itself. And then the other example that you're seeing proliferate really fast, I've got an image of the JTA vehicle up there, is this idea of shuttles and trolleys being driverless and clustering people. So that's about a 12-seater. That is one of JTA's driverless vehicles that they're driving around town and setting up demos with. And so that's something that you're going to see coming into private campuses, city streets on fixed grids, fixed routes. Next, we're going to jump over to off-road. This is where things move a little bit faster. So we'll start with Spot the Robot Dog, because we can't talk about autonomous navigation without Spot. But I want to give context of what companies are able to do. One of the interesting things about Spot right now is that it's being driven by open form fleet managers. So now all of a sudden, that proprietary technology by Boston Dynamics is being driven by anyone, as long as you have the know-how to drive that driverless package. The next one we're going to look at is ag. So what is happening in ag? That's a super exciting space, and there have been a ton of announcements just this year about driverless and autonomous electric-driven agricultural vehicles. Why is that interesting? Because we actually have very little science about most of agriculture. We'd love to know about crop densities. We'd love to know about yield, what we can expect at the end of harvest. We'd like to know how our fertilizers or our pesticides or sunlight or drought conditions are affecting crops, and we just don't know that right now. So by adding this layer of technology, the industry is headed that way. Finally, are there any drone owners in the audience? Anybody own a drone? Okay, that's good. I feel like that was planted. We had some hands go up. So if you like the idea of drones, it's pretty easy to see that you might have your own little driverless vehicle soon. I mean, that just looks super fun. And so what's happening is the operational design domain, the ODD of these off-road vehicles is different than what's happening on-road. We're not constrained by regulation, so we can do some really cool stuff. That also applies to things like the military and mining. So I'll do a quick pause. We did on the road. We talked about what's happening on the road. Who's driving it? We talked about off-road, and you got a sense for just how diverse those driverless packages are. And now we're going to look at what's actually making economic sense. I don't think either of those have a payback to them, but we're going to jump in right quick and look at what's happening in factories. So I'm going to start with the concept of islands of automation to networks of automation. Your traditional advanced manufacturing or e-commerce facility is an island of automation. It's a bunch of robotic machines or mechanized automated machines separated by people moving stuff around and trying to do stuff. In the new paradigm, driverless vehicles inside of facilities connect everything. So now we have a network of automation that smartly moves and manufactures for itself. So the first thing that we need is, I'm going to talk to you about a use case that we did with a greenfield facility. This was roughly 100 autonomous vehicles in an advanced manufacturing site, 2 states away from here, so pretty close. And the average driven miles per day is about 1,100 miles per day. So do the math, that's about 400,000 miles per year are being driven autonomously inside of a factory. The next one we'll look at is a brownfield retrofit. This was a factory we did that was existing, and it had to be retrofit with existing workers, existing equipment, existing storage systems with autonomous vehicles. In this case, the form factor was a pallet. We wanted to move pallets around, pallets of goods, empty pallets, full pallets, work in progress pallets. And this one accomplished about 900 missions per day. So in other words, 900 forklift driver put away or pickups was converted to autonomous. And what is basically driving this design? It's the interaction with humans. The single biggest design factor that we have inside of a facility is the ergonomic considerations of humans and the safety considerations of humans. So we consider that closely and intensely before we start the system design, because if the robot and the human don't work well together, the system's not going to perform. And then finally, so what are the dollars and cents? Why are companies doing this? The reason that they're doing this is because compared to manual labor, driverless vehicles in a factory are about 10 times more efficient or cost effective. Compared to conveyance, which might be the mechanized alternative, they're about twice as effective. And we have similar stats with forklifts and driverless forklifts. All right, so let me show you a little bit. This is basically 3 years worth of engineering that I'm going to show you. We summarized it down into a little 2-minute clip, and I'll just add a little color commentary as we go along. This is the idea of robot-to-robot integration. So we have a driverless vehicle that is connecting in the test lab to another automated cell. The two are talking via IoT to accomplish their mission. This is the idea of lights out. So the lights are turned out. The kind of starburst you see is the laser vision of the vehicle being picked up by infrared. So it goes to show what the vision characteristics of these vehicles are. This is a bunch of mechatronics technicians setting up vehicles in an existing facility. Here we can get a look at the fleet manager. On the left you can see all the mission orders. This is the system is saying, here's my mission orders. I want my fleet to go do these things. This would be another form factor of vehicle that can be integrated to this platform. This one is obviously specialized for a forklift. And then here's some testing of vehicles where you can see large wooden crates were set out in the setup and testing phase to say, hey, these are in the way. Can the vehicle autonomously navigate around the obstacles and maintain its efficiency? Here's another lights out test. This was my head engineer, was pretty cruel. In the middle of a factory acceptance test, he went to the power panel and pulled the disconnect. We didn't know what was going to happen, but everything there's lithium ion powered and it can see in the dark. So the system kept performing, the test was not even disrupted. You can see all the engineers got excited and filmed. Here's some of the ergonomic application. The design load for this particular unit here is about 75 pounds. It's a metal reel. And so there's an ergonomic assist added to the human. The goal here is employee retention. We want employees to have jobs that aren't backbreaking. That's what keeps employees. Here's a quick look at the simulations that we do. We take 365 days of operation, we compress it into one super fast run on a supercomputer overnight. We come back the next day and we see what broke. And that's one of the tools that we use to tweak the systems. And then here you're going to see live map updating. The little green dots our LiDAR point cloud being generated by the vehicles. They're dynamically updating the map, and you can see the overshoots of a facility. So you can start to see what some of this factory looks like to a robot set of eyes. And the reason I've got the dots highlighted is it shows you in real time the maps being updated. And then you can track for the vehicle being shown on the fleet manager to what's happening here. Those are both real-time synced of acknowledging the mission and having real-time data coming off the vehicles. There's a powered tool on top that helps. In this case, we're doing pallet lifting. So we've attached a powered tool that runs off the lithium ion of the vehicle. Okay, and then we're going to bring it home with some tech. Kelly said make sure there's some tech people here, make sure you talk about the tech. So essentially, I'm going to go really fast, but if you take notes or if you remember this is the cheat sheet of our last 3 years of learning of how to design automated manufacturing systems using autonomous technology. So the first thing we're going to talk about is the drone head. That is, probably pretty much the most important piece. Good news for everybody here, it's also commodity now because there's so many other industry pioneers. It is the AI driverless package. It's comprised of vision, sensor fusion, the actual AI software which runs as a firmware local to the vehicle, and then the industrial computing. Those vehicles you saw earlier have enough industrial computing to run a Bitcoin node on them. So, I mean, it's a serious amount of horsepower to compute all this vision that's happening and perform in a real-time and safe manner. The next is going to be the cost drivers. As people working for factory customers, e-commerce customers, we're super concerned about cost. This is a study we did for a top 5 e-com company that wanted autonomous technology deployed for them. What we found was more than 50% of the cost are the items I have lifted up there. Steel, batteries, the way that it charges, the motor drives. So the form factor of the vehicle and being robust, but also conservative with that, is the biggest cost driver in the system. Next is the tooling. What we want to have is consistent form factors. We want the same vehicle, basically a bunch of them in a fleet, and then we want a bunch of interchangeable tooling so the vehicles can do different things, different functions at a very low cost. The tooling is cheap, the vehicles are expensive. Fleet management is arguably probably the most secret sauce. A couple years ago, when I was helping JTA procure some of this, it was complete vaporware in the industry. Today, there's several established platforms, but the fleet management is the most important part, and it's what drives the interoperability of both present-day vehicles, the vehicles that you're going to have coming online in a generation 2 or 3 soon, and then other OEM vehicles that you want to work together. Also, this idea of supply chain is so big right now. This is where you get the intelligence through the supply chain. We want to have track and trace, traceability within our facilities so we know how goods got made, what got delivered, when it got delivered. We also want information going to the enterprise so we can offer insights back to the business and the global supply chain. And then the final piece that is really important to think about is communications. You would think it's just all Wi-Fi. And the early generation of these vehicles about 2 years ago was all Wi-Fi. Today, we require a spectrum approach because we have different types of data streams. We want those different types of data streams communicated over the appropriate communications protocol. So we've got our IoT. We usually call it IoT handshake when we design it in. We want 2 things talking together, confirming locally without going back to central command. Wi-Fi, if you have Wi-Fi at your house and you Zoom call a lot, you know how often it goes out. If we're totally reliant on Wi-Fi, that's how often our robots go down. And then 5G. We think every facility in the future should have its own 5G network, its own private 5G network. And then finally, more advanced communication for specialty data communication like long-range LoRa. We want to be low power consuming, and then we want to transmit with different latencies based on the data stream. So that pretty much wraps it up. And I'll come back here. The thing that my team is used to hearing me say, limit the use case. Limit the use case, limit the use case. With driverless, people want to do everything. We get it. But you're not going to be successful if you do that, or you'll be over time and over budget. So to bring it home for a successful project, limit your use case. So hopefully that helps you give you an idea what's out there, what's happening right now, and what the industry looks like.